18.2c. The point of today's assignment is to take those numbers that we know from the unit circle, including if we didn't get to it in class, I hope that you watch the video on the proper way to find the coordinates using the special right triangles. Now I'm just going to show tricky ways to find the coordinates. I'm going to use this little table. I need to look at patterns first. I don't even have the unit circle in front of me, but I know that 45 degrees is my pi over 4 angle. I just remember the 4 and the 4. Then 60 degrees is pi over 3, and 30 degrees is pi over 6. Seems backwards, but that's the way it is. And this goes 6, 4, 3. This one is pi over 2. I talked a little bit about this in my previous videos, about how the denominators of the radians on our circle are 2, 3, 4, there is no 5, go to 6. And then this one, 0 degrees, is 0 pi, and if it's a pi on a 0, all I really need to say is 0. I'll memorize those. Then I'm just doing this funny little pattern thing. I'm doing square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Just because it's easier to memorize it that way than the other way. And then I have square root of 0 is 0, and 0 over 2 just gives me 0. Square root of 1 is 1, and 1 over 2 is just 1/2. Square root of 2 over 2, can't do anything with that. Square root of 3 over 2, can't do anything with that. Square root of 4 over 2 is 2 over 2, which is just 1. And then I'm going to take that same pattern going backwards. I'm going to say, I'm just going to take the pattern backwards without even doing the other part. So, 0, 1/2, root 2 over 2, root 3 over 2, and 1. Those are sine and cosine. Tangent is the sine of a theta divided by the cosine of theta. So, for this one, I'm going to do 0 over 1. I'm going to do 1/2 divided by root 3 over 2. I'm going to do root 2 over 2 divided by root 2 over 2. I'm going to do root 3 over 2 divided by 1/2. And then I'm going to do 1 over 0. Then I'm going to simplify each of those a bit and say 0 over 1, just 0. 1/2 divided by root 3 over 2. I'm just going to write it over here the long way, and then I'm going to erase it. 1/2 divided by root 3 over 2 is 1/2 divided by root 3 over 2. I'm going to flip that fraction and call that 1/2 times 2 over root 3. Cross out the 2's, get 1 over root 3. I don't really want to do all that. Shorter way to look at that is, if they both have 2, cross out the 2's, and then you're working on 1 over root 3. But I'm not allowed to leave a root on the bottom. So now I'm going to take, I want to get rid of the root 3 on the bottom, multiply by root 3, top and bottom. Remember, that means I'm multiplying by 1, so I'm not changing the value, I'm just changing the way it looks. That turns into 1 root 3, and root 3 times root 3 is root 9, which is plain 3. Let's look at the next one. I could use that same little shortcut, wipe out the 2's, But then what do I have? Root 2 over root 2. That's just 1. Next one. Let's wipe out those 2's. I have root 3 over 1. And root 3 over 1 is just root 3. And then 1 divided by 0. Is that 0? You cannot divide by 0. If you have 0 on the bottom, the answer to that is undefined. Now, if you watched my other video, or if you listened to me in class talking about this, you know that those are the same numbers that I found for the coordinates using the 30, 60, 90 triangles and the 45, 45, 90 triangles. The only question is, how do they go on the circle? So let me show you how those go on the circle. This is a different way of getting the coordinates for the circle if you don't want to go through the whole 30, 60, 90, 45, 45, 90 triangles. I wanted you to see that first because I wanted you to understand that's where it comes from. And we're just going to use a pattern to get it in there. I put the table down here in the corner, but I want to just say, when I want to set up my unit circle, I just do this. Root 0 over 2, root 1 over 2, root 2 over 2, root 3 over 2, root 4 over 2. And I just set it up that way because that's how I remember it. Root 0 is 0, 0 over 2 is 0. Root 1 is just 1, so this is 1/2. This one doesn't simplify. This one doesn't simplify. And this one is, root 4 is 2, and 2 over 2 is 1. Those are the only numbers you're going to get for your coordinates. Let's talk about what we know about any circle, or about anything on the XY axis. This is called a unit circle, which means that the radius is 1. So if I wanted to do this point out here, I would be doing 1 to the right and 0 up. If I wanted to go to the left, I'd be going 1 to the left and 0 up. If I wanted to be going to the top, I'd be going 0 left and right, 1 up. Take it down to the bottom, 0 left and right, 1 down. Those are the coordinates there. And then I can fill in the coordinates for the rest, and they're going to be using these numbers. Let me look at quadrant 1. Quadrant 1, at the top, right there, right there at the top, it gives me 0 for my x. So my x's are going to go 0, 1/2, root 2 over 2, root 3 over 2, and down to that 1 that I already know. My y's start with 0 out here straight out to the right. So the y's are going to go 0, 1/2, root 2 over 2, root 3 over 2, and back up to 1 on top. I'm going to do that in all 4 quadrants. Before I get too carried away, though, I want to stop and think about the signs. On a graph, everything over here in quadrant 1 is positive because we go to the right on our x's and up on our y's. In quadrant 2 here, I'm going to the left on my x's, so my x's will be negative, but I'm still going up, so my y's are going to be positive. Down in quadrant 3, I think about my x's are going to the left, so I have negative x's. My y's are going down, so I have negative y's. Quadrant 4, I kind of covered it up, that's okay. My x's are going to the right, so they're going positive, but my y's are going down, so they're negative. So I need to think about those things. So maybe before I draw in all those little things with the radicals, I'll think about putting a negative sign on the x values for that one. In quadrant 3, I'll think about putting a negative sign on both the x and the y. Don't put it on the outside. It's not the same thing. Negative on both the x's and the y's. In quadrant 4, I need to put a negative just on my y values. That way I won't get lost when I'm working my way around. Okay, I'm back to quadrant 2. In quadrant 2, the x's start with 0, so the x's are going to go 0, 1/2, root 2 over 2, root 3 over 2, down to the 1 I already know. My y's start with 0 on the left-hand edge, so the y's are going to go 0, 1/2, root 2 over 2, root 3 over 2, and back to the 1 I know already knew on the top. Let's look at quadrant 3. Looks like my y's start with 0 here at the pi 180, so the y's are going to go 0, 1/2, root 2 over 2, root 3 over 2, back to the 1. My y's start with 0 on the bottom, so I'm going to work my way up from there. 0, 1/2, yes, I need a comma, root 2 over 2, root 3 over 2, back to the 1 I know. Let's look at quadrant 4. Looks like I start with 0 on the x's at the bottom, so it's going to go 0, 1/2, root 2 over 2, root 3, oh, very good, 3, root 3 over 2, back to 1. My y's are going to start with a 0 right here, so 0, 1/2, root 2 over 2, root 3 over 2, and back to 1. There's all my coordinates. That's a different way to do it without using the 30, 60, 90 triangles. I wanted you to know the 30, 60, 90 triangles and the 45, 45, 90 triangles so you could understand why that happens. But that's just what happened. This is talking about sine, cosine. If you look at some of these, like if you look at the 0, you see that your sine value is your x value. Your sine value is your y value, because it's 0. Your cosine is your x value. Your tangent is your y over your x. Let me go to the next page and talk more about why that is true. Okay. Here it is again. All the coordinates typed in so that we can see them clearly in case my writing might have been a little sloppy. Let me take and draw a picture on here. And I'm going to draw right here. It's got to be a 30, 60, 90 or 45, 45, 90. It's not the same on both sides. So it's here telling me the long side in the x direction is my root 3 over 2. The short side in my y direction is my 1/2. But let's think about opposite and adjacent instead. The opposite side, sine is always going to be the opposite leg over the hypotenuse. Cosine is going to be the adjacent leg over the hypotenuse. And the tangent is going to be the opposite over the adjacent. Let's see how that relates to this circle. If I'm looking at a 30-degree angle here, and I wanted to find the sine of that angle, I would say, what's opposite from that? 1/2. And since 1/2 is up and down, it's the y value. So if I'm looking at my theta over here at this angle, if I'm looking at my theta angle as being at the center of the circle, so this little thing is right at 0, 0. I have to say something about theta again. Theta, it's like a O with a line through it. Please do not make it a slash. That is not the same thing. here's opposite. And opposite, because it's going up and down, is always going to be my y value. Here's adjacent. And adjacent, because it's going left to right, is always going to be my x value. And then this diagonal one is my hypotenuse, and it's always a 1. So if I'm talking about the sine of an angle, I'm going to deal with the side that's opposite from that, which is y, over the hypotenuse, which is 1. Sine is just the y value. Cosine is the side adjacent to that, which will be my x, because it'll be the left and right line, over my hypotenuse is 1. It's just x. Tangent is my opposite over adjacent, my y over my x. Another way to look at that tangent would be, said this in our table, tangent theta is the sine over the cosine. So this could be tangent theta equals opposite over hypotenuse, adjacent over hypotenuse. Wipe out the matching hypotenuses. We still have opposite over adjacent. Okay. Let's look at what's positive, what's negative. So if I'm saying that for each point, the cosine theta is the x part of it, and the sine theta is the y part of it. Then I'm talking about in quadrant 1, which we already said is positive, positive. Cosine turns out positive, sine turns out positive, and when I divide them, it's still positive. If I'm talking about quadrant 2, I said the x's are going in the negative direction, and the y's are still going up. That means the x's, which are the cosine, are going negative. The sines, which are the y's, are going up to the positive. And if you divide a positive and a negative, you get a negative. Quadrant 3, x's are going left, negative. Y's are going down, negative. So my cosine is negative and my sine is negative. But if I divide sine and cosine, negative divided by negative is a positive. Quadrant 4, my x's are going to the right, positive, but my y's are still going down. That means my cosine, which is my x, is positive. My sine, which is my y, is negative. If you divide a positive and a negative, you get a negative. Remember, cosine is your x, sine is your y. Divide them to get your tangent. This is x, this is the y. X, y, x, y. One way to remember those words is all students take calculus. Not true, but it could help you remember. All students take calculus, or any other acronym that helps you remember that. My husband's classes once got him to sign up to supervise a club that they called the After School Tasting Club. And all they did is got together and ordered food and ate it and talked. But in this section, everything is positive. In this section, only the sine is positive. In this section, only the tangent is positive. In this section, only the cosine is positive. For some people, that really helps to remember what's going on. If it helps you, great. For some people, it's easier to just memorize these things. So, I have the circle here, but what I really want to show you is if I only knew the first quadrant, if I didn't know any of this stuff over here, could I still figure it out? Okay. If I had an angle of 150 degrees, now I know that 150 degrees is right over here somewhere. If I had an angle of 150 degrees, first thing I would want to know is what quadrant is that in? My quadrants, again, 1, 2, 3, 4. That is in quadrant 2. And I don't want to know its reference angle. It's closer, when you're trying to do the reference angle, you want to say a reference angle is the positive distance to the nearest part of the x-axis. So think about, is it closer to 0, 180, or 360? I think that 150 is closer to 180, so I'm going to think 180 minus 150. If you get an angle that's between 0 and 90, you've got your reference angle. 30-degree reference angle. Now that I know it's a 30-degree reference angle, I know that I'm going to look at those things in that 30-degree column there. I do need to know a little bit about my signs, so let's think about my signs first. In quadrant 3, my signs are x's are negative, y's are positive, left and up. So, or think of it this way. All students take calculus. I'm over here in quadrant 3, and in quadrant 3, only sign gets to be positive. Everything else is going to turn out to be negative. I can decide that before I start. And then I can look at my column over here and say, in the 30-degree column, because this is a reference angle of 30 degree, my sign is 1/2. My cosine, √3/2. And the table tells us the tangent also, but unless you're going to draw the table every time, I want you to show me some work for the tangent. The tangent is going to be, I know it's going to be negative, but I'm going to get that negative off there for the moment. It's going to be the sine divided by the cosine. So I'm going to take the y value divided by the x value. Remember that this was my x value and this was my y value. The y value divided by the x value, or the sine divided by the cosine. So I'm doing 1/2 divided by √3/2. And just like before when I was taking my shortcut, I said, wipe out those 2's and just deal with 1 over √3. But I'm not supposed to have a radical left on the bottom. So if I want to get rid of √3, I'll multiply by √3, which gives me √3 over plane 3. But we decided in the first place that this should be negative. If I actually look at these numbers, I had a negative on the bottom, a negative on the bottom. I still have a negative on the bottom. And it really doesn't matter whether I state my final answer with a negative on the top or a negative on the bottom as long as I get it there. In fact, notice I didn't worry about the negative till I was done with worrying about the rest of this thing. So let's do 270 degrees. What quadrant is 270 degrees in? 270 degrees is straight down here. Is that in quadrant 3 or quadrant 4? You really can't tell because it's really on the borderline between the two of those. So even though the homework asks you for the quadrant, we're going to say that it's really on the y-axis. But I still need to know, is it on the positive part of the y-axis or the negative? It's on the negative part of the y-axis. That's a good enough answer for that. It's on the negative part of the y-axis. Or you could say between quadrant 3 and 4. But I think it's easier to just say negative part of the x-axis. Reference angle. How far is it from that 270 degrees to the nearest part of the x-axis? Well, either way is the same. it's 90 degrees. Switch back to the normal pen. 90 degrees. At 90 degrees, I have to think about the coordinates that I know. And 90 degrees is on my table already, so I could just say from my table, sine is 1, cosine is 0. When I do 1 over 0, I get undefined. So this is my answer for the tangent, cosine, sine. Of course, they also asked you for these. I guess I could circle those too. In your homework for this assignment, you don't have to circle all these answers because they're making a table with all those things in it. That's some degree ones. Let's look at some radian ones. Okay, I have all the same stuff here with the unit circle, my little table, my all students take calculus to say in this section they're all positive, in this section sine is positive, everything else is negative, in this section tangent is positive, everything else is negative, in this section cosine is positive, everything else is negative. That'll help us as we go. So I'm looking for 5 pi over 3. And if you know anything about the unit circle and you know where it is, great. If you don't, search for it on the unit circle. For today, you're only going to have ones that are on the unit circle. Tomorrow, you might get some that have an extra rotation around, so we'll have to use coterminal angles to adjust it just a little bit first. But if I was looking at this and I didn't have my unit circle beside me, I would say it's got a 3 on the bottom. I'll call this 3/3 of pi, double this to call it 6/3 of pi. We did a lot of that in the previous assignments. So if this is 5/3, I'm saying, is it closer to 0 or 3 pi over 3 or 6 pi over 3? I think it's closer to 6 pi over 3. So I would say, how far is it? Pi over 3. Please do not tell me that the reference angle is 60 degrees when it was given in radians. Make sure you still give it in radians. And which quadrant is it in? It's over here somewhere. So I would say that is in 1, 2, 3, quadrant 4. If you wrote 4 like that instead of the Roman numeral, I would not mark it wrong. Okay. So if I've got pi over 3, I'm just going to look at my table and I'm going to take the pi over 3 line and I'm going to work with those numbers. I'm going to think about my sines. In this quadrant, I have a positive cosine and I have negatives on my sine and my tangent answers. And then I'll just take these numbers. Sine is root 3 over 2. Cosine is 1/2. Tangent is y over x. So root 3 over 2 divided by 1/2. I'm going to wipe out the 2's, take the shortcut and call it root 3 over 1. And root 3 over 1 is just root 3. Don't forget, keep the negative as part of your answer there. So this is my answer for tangent theta. This is my cosine. This is my sine. Remember that sine theta is the y value, cosine theta is the x value, tangent theta is the y over x. Now, if I didn't have my little table to work with, I could just go find this thing on the circle and say 5 pi over 3. Looks like we're talking down here somewhere. And I would say this is my cosine theta, this is my sine theta, and I could just pull them in over here. I would say cosine theta, 1/2, sine theta, -√3/2, and then I would still ask that you show the work for the tangent, unless you're going to copy that table on the top of your paper every time you do an assignment. Let's do one with 5π/4. Hey, let me talk reference angle for just a minute. Do you remember that I told you that if the bottom of your fraction was 2, 3, 4, and 6, the reference angle was just pi over whatever you had, π/4. That's all. Okay. What quadrant is this in? If I didn't have my circle appear, I could just say, think about 4π/4, 8π/4. Why did I choose 4? Because of the 4 on the bottom. And say 5π/4, looks like it's got to be a little bit past 4/4, so it's around there somewhere. That means it is in quadrant 3. And I know that if I'm in quadrant 3, all students take calculus. So in quadrant 3, I get only tangent gets to be positive. Everything else gets to be negative. I'm going to look at the π/4 column on my table, and I'm going to say √2/2, √2/2. And when I do tangent, and I divide -√2/2 divided by -√2/2, can you tell anything divided by itself is just going to be 1? So this is my answer for tangent theta. There's my tangent, there's my cosine, there's my sine. The trig mega table doesn't actually ask you for tangent, but you have to do tangents on the next assignment after that. Let's see. I think that does some of everything. I don't think that I'm going to do a video with part of the trig mega table filled in, but maybe I'll decide sometime later tomorrow to do that if I hear that people are struggling with how to fill that table in. Okay, that's enough for now.